Hello and welcome to another amazing episode of Agency Automators. Today I'm joined by my amazing co-host Jordan Chu. How are
Hey,
you
hey,
today,
hey.
sir? You're
Doing
doing
well.
great?
Super excited.
Yeah, me too. And we're also really lucky to be joined by, is it Elias Dabbas? Did I pronounce that perfectly?
Elias is fine. Elias, all works.
What do you prefer?
The way you read it, that's fine.
Oh, thank God. Okay, so today we're super stoked because we're going super deep into data science and Python and how the two are joined together. Elias, can you tell us a little bit about yourself, about what you do, and about some of the stuff that you've been working on and building?
Sure. Thanks for having me.
Of course.
Honored to be on the show and very happy to meet you face to face, finally.
Yeah.
I've been working in online marketing fields for like 15 years now. Um, some SEO, some SEM, some general consulting. And I stumbled upon this thing called data science 5 years ago. I heard the word 17 billion times. I was like, what is this? And I didn't know, like, I was just curious. And a few weeks later, I realized how this fits perfectly with what I already do, because it is the science of working with data. And this is what we do. We analyze data, we visualize it, we try to understand it, we try to make decisions based on it. But this is like at a different level with programming and machine learning and stuff. So I got hooked very fast, and I started realizing that some stuff is always, you repeat that stuff all the time. So these things became functions, and those functions became a package, and some of those functions became tools that users can use without code, which, and we'll take a look at some of them today. And yeah, I liked this thing very much, and going deep.
So tell us a little bit about your coding stack. Most people think of you as a Python guy.
Okay.
What other tools do you use in your daily workflow?
I started with a bit of R, so
Mhm.
I know some R, which was great as a starting point in this field, and mainly Python. I mean, I use the command line. But it's mainly Python that I use in my work and in the stuff that I develop.
Mm. And was there a moment or a package where all of a sudden you started to understand the opportunities that you'd been missing before you started to work with data the way that you're now working?
I remember there was a week when I discovered that code that we write is basically the equivalent of human labor, frozen,
Huh.
waiting there just for you to repeat it. Now, if a software engineer is listening, they're probably laughing at me because you just discovered computers. Yes. But the discovery is, so I thought of computers as two things. You're either a user who uses point and click software, you just select something from the menu, and there's the other extreme where there's developers who talk to the computer, to the insides of the computer.
Yeah.
But I never knew or never thought that you can use software, or you can use programming to do work. So that was a nice realization, is that you can become a software user without having to become a software developer,
Mhm.
because that's a different level. Like if you want
Yeah,
to
yeah.
develop packages and applications that people are going to use, that's a different story. But you can get started very fast with software to enhance your own productivity and your analysis skills. So that was a nice one. The labor thing was, so a simple example. Let's say I give you an Excel sheet, and I say, please open this sheet and give me the maximum and minimum of every row, every column, and put them in this other sheet. Now, what you're going to do is you're going to take the mouse, look, click, the steps. But with programming, we do it by writing code. So the first line says open file. The second line says get the maximums. The third line says something. And this text, once it is saved, if I ask you to do it again, it's going to take you one click to repeat this. I know I'm saying something ridiculously obvious to many people, but looking at it from this perspective and knowing that we do the same thing over and over with many different accounts and clients, I was like, wait a minute, this is cool.
Yeah, totally.
So, and to that point, like for me personally, that's one of the reasons why I've been so attracted to automation, is because it not only speeds up the process of doing something, but it also takes out that human variance of, there could be errors, there could be, cases where, someone doesn't do something properly. So you're essentially reducing that risk.
Absolutely. Copy, paste, copy, paste, copy, paste enough times.
I had that happen to me. I was building out a data pipeline for an agency, and I had the agency proof the schema of each of their tables that we were going to build.
Okay.
And it included date, page, query, impressions, click-through rate, average position. Do you hear anything that I missed?
The quick title.
So we're doing GSC dimensions and metrics. Date,
okay.
Page, query, impressions, click-through rate, position. How did I forget clicks?
Oh,
that minor detail.
Built the tables.
Who cares about clicks, right?
Yeah, who cares about that? So I built out all the tables and the manually, because I hadn't automated the process yet. And then after I did that, I was like, I am never fucking doing that manually ever again.
Absolutely. Oh, yes.
Because I made the mistake. It's exactly to your point. It's like, you cannot, for certain activities, you have to let the computer run the table.
Absolutely.
Sorry about that.
Fully agree.
And Elias, I think this is a good segue into what we were discussing on our pre-call about, why people actually are attracted to like computer programming or Python and what they really want to get out of it. Learning additional things where they don't actually need to.
Sure. I mean, it's as I said, it's augmenting your own skills with something different and faster without changing your career track, how you think and how you work. Because once you start learning to use a programming language to actually do some work, like it was also there was another interesting moment where a few months after I started, I realized, wait a minute, I'm not using Excel anymore. That was very interesting. So and many things, like for example, I once ran an analysis of Twitter analytics table for one of the clients, and you immediately realize that every analytics table from Twitter is the exact same table for every client. It just has different numbers and different tweets. So the code that works on this one works on everything else. Yeah. So the stuff that I like to do, for example, say the tweets per weekday, which is not included, or whatever I want to do is just the same thing. So you can run it very quickly and do things very fast. Otherwise, and many of these things you wouldn't do otherwise. Like if we didn't have Excel, drag, double click, we're never going to say equals 1 times 1.3 equals 1,000 times. So it gives you the opportunity to do stuff that you wouldn't have done before or you wouldn't have thought possible.
Mm-hmm.
In your own daily practice, when I looked at advertools, I was like, holy smokes, it has so many different functions. It has a bunch of different topic areas. Like in your day-to-day, are you doing PPC? Are you doing content marketing? Are you more of a technical, like what is your actual practice look like day to day?
So I mostly used to do PPC and SEO at the same time.
Yeah.
But this is more like, many of these tools I use because everything helps everything else. Even if you're
Right.
doing SEO, you want to see what's going on in social media. If you're a social media, you want to see what's going on in SEO.
Yeah.
So and many times it's like the addiction of, wait a minute, I can do something that can help these people. Let me build it.
Yeah.
So it's both.
Very, very cool. Okay. So this feels like a great jumping off point to jump into advertools and anything else you want to share. I set up screen sharing, so you should be able to just click the screen share button.
Yes, I
Do
can.
you want
I
to
can
take
see
us
it.
through your notebook and see where that goes?
Sure.
Killer.
Shall I
I
start?
like that. Yeah, let's jump in.
Okay. So I'm sharing my screen. I think you can see now.
Yeah, totally. Looks great.
Okay. So the thing that I want to share first is the crawling process.
Yep.
Okay. So I'm here in IPython, which is a REPL of Python. So I'm going to crawl a page or two of the Django website just to show you how it works, and then we'll go through the analysis process. Okay?
Yep.
So I'm going to import advertools as ADV and pandas as PD. Okay? Now, we have the crawl function, which starts with a URL list. Okay? So I'm going to take let me just copy and paste that. I'm going to take this URL and so URL list could be a single URL or could be like as many as you want. And then you give it an output file where you want it to save the results. So I'll put it on my desktop and I'm going to call it Django1 dj1.jl. It has to be a JSON lines file. 1 second.
Is that the same
Okay.
thing as the new line delimited JSON?
Yes, it's the same as JSON, but each line is independent.
Right.
So
And there's a new line
you can just
symbol at the end of the line?
yes, the new line at the end of that. But each one of them is independent from the other. So
Right.
this way you can append to the file instead of having to save everything in memory and dumping one object to your file.
Got it.
Okay. So
out of curiosity, do you have to specify an output file, or can you return it as like an actual big JSON object?
no, you have to give it as a file, because typically you would want to crawl many pages. And it might become like gigabytes and gigabytes of data. So you don't want to put it in memory. You just want to keep every 100 pages or so just get appended and frees up your memory.
Got it.
Okay.
Okay. So I'm going to do a very simple crawl, which is going to crawl just this one single URL and going to dump the results here. I'm going to hit enter. And it's going to start crawling. So this is it's starting up. You'll see some logs here about the report. This is a report of what happened, and it's done. Okay, so let's start with, we can open the file with pandas. We read JSON, and this is the file. We said J1L. Lines is true, so because this is a JSON lines object. And let's see what we have here. And this is our data frame. Okay, so it has one row because it has just one URL, and it has a bunch of attributes, which we're going to go through right now. Okay, the other way to do it is there's the other option. Let's take a new file, call it DJ2, and you have the option to follow links, and you set it to true. This way it's going to go to the start URLs over here and extract any links and follow them, and extract every link and follow them recursively until you finish the website. Okay, It's going to go through everything on this domain and its subdomains. So if there are links to Twitter, it's not going to go there. So I'm going to show you how it goes. I'll stop it in a minute, but just so you're familiar with the process. So it's starting up now. These are just messages on what's going on, which see here we have filtered offsite request to another domain.
Oh, that's cool.
And every single page you have a log message telling you what happened. So filtered offsite and so on. Okay. So I'm going to stop this now. I'm going to interrupt it with Control-C. And yeah, that's how it works. There's a few other options, but is this clear how it works? Like, is it easy to use? And
do you prefer using your own crawler to off-the-shelf tools now that it's been developed so much?
Now I'm enjoying it. Yeah. Well, that's for you guys to decide once you see if it makes sense to you.
Yeah.
Okay, so this I crawled the Django website using this line of code.
Yeah.
The output file was this. Follow links was true. You have another option which is called allowed domains. So I restricted my crawl to only these two subdomains, the docs and W domain. There was another one for tickets, software issues. That was like 500,000 URLs.
Wow.
So no need. So there's a bunch of settings that you can customize here. So this one is very interesting. You remember the logs that we printed or that were printed. If you specify a log file destination, it will save these as a text file for you.
Cool.
So you can see what happened during the crawl. If you have issues, if you have scraping issues, something was blocked by robots files, whatever, you get all the thing in a file. And job directory is where this is very interesting for pausing and resuming. So once you specify this, it creates a directory with all the stuff that's been crawled. So if you stop it and restart it again, it will skip the ones that have been seen before.
Huh, very cool.
So if you want to like crawl this full website across in 2-3 weeks and just get 1,000 pages every day, you can do it this way. Otherwise, you're going to have to recrawl every time.
That's super slick. I like
Cool. it. Okay, so once you crawl, you get a data set that looks like this. This is just a sample. So a few things on how things are structured. You have a URL column, and you have a bunch of columns here about page elements, response headers, request headers, and many things that we'll see right now. But a few notes on how this works. So you have a few options. The first one is, this is the H1 tag, let's say. You have a value here, you have a value here, and you have this is not available. Okay. Now what this means is that there was no title, there was no H1 tag on this URL. Now this is different from an empty tag, which is here, which is like this one. So this is an H2 tag. It's a valid H2 tag. It's ridiculous, but it exists. Yeah. But there's a difference between a missing value and an empty value. Does that make sense?
Yep.
Yep.
Okay. And the meaning of missing values is different, of course. If you have a missing H5 tag, that's not an issue. If you have a missing title tag, it means a different thing. Yeah. And the final thing is that on many pages, you have multiple values of the same element. H2, for example, you might have 10 of them. So in these cases, they are just one string to be consistent, but they are separated by this intentionally weird two @ signs. So once you want to get the H2 tags of these URLs, you can split them using these two characters, and you'll get a list of the H2 tags, as you can see over here. Okay.
I use that as a splitter as well.
The two @ signs?
Yeah, we were
Really?
Yeah, we were talking with Rachel at Deep Crawl, and they had their split that they typically use is some symbol repeated 3 times. I
Okay.
don't remember what it was, but I was like, oh, it was three colons in a row, colon, colon,
Okay.
colon. And when
Uh-huh.
I looked at it, I was like, oh God, what part of JavaScript don't I understand? Like, I was like, oh no, is that a way of defining a class that I don't know yet?
No, it's much simpler than you.
I like it.
Yeah, it's just commas and other stuff can really be mixed with other things. It was just something highly unusual, and visually it's like weird. So if you don't know, you'll have to look it up in the docs and so on.
Yep.
Okay, so that's it about the structure of how things work. So you can save it to CSV, of course, because it's a data frame, to make it easier to share with people, because JSON lines maybe not, you can just save it as, because it's a data frame, you can convert it. So the first thing we do here is create a variable called crawldf, data frame, read CSV. This is the path, and there's an option to parse dates. So I'm telling pandas to these columns to interpret them as dates. So you can, if you can go here and say, give me the weekday, of course, or give me the minute, or the hour, or the quarter, or any date time attribute of that column over here. Low memory equals false. I'm not sure why this was required, but sometimes it's an option. I don't want to bullshit.
Quick question on pandas and parse dates. How flexible is it with the inputter? Does it expect year, dash, month, dash, date?
No, it's very flexible. It can take so many different formats. Actually, Pandas was developed with financial applications.
Okay.
The author worked in a financial company, I think,
Okay.
and dates and times and time series and stock prices per millisecond make a huge difference. So
Got it.
It has very strong support for dates and times.
Got it. Okay. So it's like moment.js. It can take anything and output
Probably.
it. Okay.
Probably. So this is the first 3 rows of the data set. We have 35,463 rows and 59 columns.
Poof.
Okay, we'll go through these quickly. So in one thing that you can do quickly is, this is a sample log message where this URL was blocked by, sorry, do you see the, how do I, okay. You see better this way?
It looks the same, but we can see.
Oh, sorry. Okay.
You can make it a little smaller too. Like I mean, for me anyway, it's quite big. But
okay.
I have a huge monitor. I don't know, Jordan.
It looks
Cool.
great on laptops.
Yeah.
Okay. Wonderful. So this is one of the messages that shows that this URL was forbidden by robots.txt. So we go to the log file, and with a regular expression, we say extract all the lines, and from these lines, extract the URLs that have been blocked by the robots rules. And it's a simple loop. We go through the lines one by one, and if it has this expression, extract it and put it in a list. And we see that we have 26,515 URLs that were blocked by robots.txt. Okay, so we have this in a list, and we can check if this is good, if this is bad, if there's errors. We still don't know. Like, but we know that these were blocked by some robots rules. Okay.
Mm-hmm.
Another interesting thing is a function that downloads sitemaps to a data frame. It's called sitemap to df. So you simply give it, this is how it's run, sitemap to df, and you give it a URL of a sitemap. Now you can give it a sitemap, a regular sitemap, or you can give it a sitemap index. And if you give it a sitemap index, it will recursively go through everyone and put them all together in one data frame, just like this.
Ooh, that's juicy. I was going to ask you if it was recursive.
Yes. So this is what you get here. You get the location, the lock, change frequency, and priority. This is what was included in the sitemap itself. And these columns are, you can think of them as metadata. So this shows which sitemap this URL was extracted from. Okay, this shows you the site in megabytes, and this tells you when the sitemap was downloaded, because you might want to download it again and compare version 1 to version 2, and you can see which one was first, before, and after, if you want to compare them.
Are you
Okay.
ever comparing URLs to see if there are multiple sitemaps? And to see if like the last update dates are different or anything like that? I've
You mean
never
the
thought
same-
of doing that. I was just curious, like I haven't had a tool where I could see where my URL was extracted from. I've just used the recursive thing to build a crawl list and then crawl. And I haven't been tracking which sitemaps a URL came from. I just didn't know if there's any value in thinking about that or not.
Well, I mean, there's no immediate thing that's actionable by this.
Yeah, I didn't think
but
so. It's just,
the information is, I think, very valuable if you're debugging, if you're quality checking what's going on. Is this in the correct sitemap? Are we doing things like there's no immediate action that you're going to take here.
Yeah.
But from a marketing perspective, it's important to, or it's helpful in analyzing a website's content, right? So you have an e-commerce site that looks like a fashion website at the homepage, but how much do you have in shoes? How much do you have bags? How many t-shirts do you have? Is it a 90% t-shirt and 10% shoes? Is it dresses? Is it skirts? Is it like, what kind of split do you have? This can come, but it also depends on the naming of the sitemaps. If the sitemap is called sitemap 1, sitemap 2, there's nothing to learn there. So here we can count the number of URLs per sitemap, and we can see that they're quite descriptive. So we have languages: English, French, Indonesian, Portuguese, and so on. And there's a generic one over here. And these are the numbers of URLs per sitemap. Okay?
Mm-hmm.
So one thing that you can immediately do here is compare the sitemaps, the URLs in the sitemaps, with the URLs that have been crawled. And you can easily do a set operations. Are you familiar with Python's set operations?
I've never heard of them.
no. Is it
Okay.
sort of like creating an array, but in Python speak?
No, sets
set.
like in math speak.
Yeah.
Let me show you a quick example, because I
Great.
think it's really helpful.
Good.
So I'm gonna create a set. It's gonna be called my colors, and it will have blue, green, red, and yellow. Okay, so just like in math, it is a set. We use the curly braces for that. And your colors is going to be a set of blue, green, orange, and whatever, purple.
How are these different than, so what I get confused coming from JavaScript is arrays in JavaScript, and thinking about, like, to me, I immediately go, okay, so what's the difference between a set and a dictionary?
Sure. The set is an unordered bunch of items.
Oh,
and they're unique. They have to be unique. So if I said
right.
blue, blue,
That's
blue,
like
green,
okay.
yeah, it
like JavaScript.
deduplicates them for you.
Yep.
There's no order, so it's like a bag. I think data structure called a bag in some languages. So there's no sense in getting the first element of here. There's no first element in this set. Okay. So the interesting set operations that we can do is my colors dot intersection your colors. Okay, so this gives me the stuff that's in my colors and yours. just like Venn diagrams.
Yeah.
Okay, we can say my colors dot union your colors, and it would put them together and deduplicate them.
And this is all natively in Python.
Yes, yes.
Okay.
So another thing is set difference. So I took the set of the sitemap df lock column and told it to get the difference between this and the crawl df URLs. So this variable is called in sitemap, not crawled. And this is the exact opposite operation where these are crawled, not in sitemap. So we have 2,000 of those, and we have 19,973 of those.
This is the exact function that I'm building right now for my data pipeline, where you have like an array of dates, and then you're looking for dates that didn't get data, and then you go crawl those and add those to BigQuery. This is like
Cool.
the exact same thing, except it's a little different in JavaScript and a little harder, or not harder. It's just more work.
Cool. Yeah. So here you can see immediately if you have any issues with any differences between things that should have been here, shouldn't have been here, and you can easily extract these if you want. Okay. So we can start by exploring the crawl df. This is the name of the variable that refers to this data frame. One of the most obvious things to do is get the status codes and get their value counts. That's, I don't think we need to explain this. 200 and 404s, we have these 3,400 404 pages. There's a crawl time column, which shows you the exact moment when when this page was crawled. So what we can do is get the minimum value of that column, subtract it from the maximum, and we can see that the crawl took 0 days, 5 hours, 18 minutes, and the crawl per second was 1.8. Almost 2 pages per second were crawled in this process. Okay.
So 36,000 URLs in 5 hours and change?
Yes.
Okay.
So one thing I realized in trying to analyze these things is you can learn a lot by simply counting the values of each column. Okay. So this is a bit of explanation that we'll go through. This is a video showing how you use it. But here we have this interactive small functionality here. So this dropdown contains all the names of the columns that we have. Okay, so let's start with an example of the title tag. Now, what it does here, first, let's see here, number of titles, we have 35,000 and some, the exact same number of pages. So we have 1 title tag per page on the website. And this is the table. So I'll just walk you through the columns and what they mean, so we're clear, and we can do the same thing for other columns. So this is a simple count. So this title tag has been repeated 13,171 times in the website.
Dope.
And this has been repeated 3,400 times, and so on. Nan is not available, so we have 195 pages that do not contain this element, which is a title tag. This is the cumulative count. So this plus this equals this, plus this equals this, and you can see they accumulate here. This is the percentage. So 13,000 is 37% of 18,000. This is 9.6%, and so on. And one of the most interesting one for me is usually this one, because by here, you know that we have 10 titles that form almost half of the title tags of the whole website.
Yeah, that's crazy. And
Okay.
a problem.
Sorry?
That's a problem.
Of course, yeah.
Yeah.
And everything else is bundled in something called others, because you don't want to see a table that has like 5,000 rows, but you can interactively play with this here if you want to see a bit more. you'll see more. Okay.
Does
And it-
Pandas give you the ability to do drill down by clicking into one of those columns?
This is not Pandas. This is a combination of Pandas, but it allows you to do it by filtering.
Oh, sorry. It looked like data. It looked like a data frame. I apologize.
It is a data frame. It is a Pandas data frame. It's
Okay.
just that this IPy widgets thing is
Yep.
is connected to it, so you don't have to write the same code. Okay, show me the counts for the title tags. Show me the count. It's just we're choosing them here.
Yeah.
Okay. So we can look at viewport. These are the counts. We have 207 pages that don't have it. We can look at the character sets, 207 pages that don't have it. The majority of are UTF-8. We can look at the H1s. Now, remember, we have multiple elements in some cases. So here we see that we have 118,000 H1 tags on the same number of pages with an average of 3.3 H1s per page. Okay? And these are the counts, and these are the cumulative percentages and everything. So 82% of my H1 tags are these.
Wow.
Okay? So far, you don't see any programming, development, web framework, or any of these keywords here.
Looks like they need help.
It's an open source project.
Yeah.
So you can do the same thing for H2 tags to see what's going on. You can see links might be interesting. It's going to take some time because I remember there was like, yeah. So on the website, we have 3.7 million links. And on these pages, so on average, we have 105, almost 106 links per page. And this is how they are distributed. So links are not as, like, they're more uniformly distributed than the other things. So the top link is repeated, forms like 2.8% of the whole links set. Makes sense?
Totally.
So you can interactively choose whichever one of those might be interesting for you.
Yeah.
Canonical, and so on. Okay.
Is this Kaggle notebook public? Is this something that someone can drop in their
Absolutely.
crawl list and get started? Okay.
That's the idea, actually.
That's
so you
the whole idea. Yeah. That's what I thought.
this is intended to be a template.
Yeah.
So you can just upload your own data set and you can run the same thing.
That's awesome.
It should work for any other thing because it just takes whatever columns you gave it. So if you have other column names, it should work. In some cases, it won't because there are specific things, but in general, you could. So another thing we can do is understand the structure of the URLs that we have. Okay, so URLs generally have, beyond the domain, we have directory 1, directory 2, directory 3, up to directory n, right? And they mean different things in different websites. Sometimes you have the language code, sometimes you have the author name, sometimes you have, there's no standard on how to structure your directories on URLs. But in general, the first one is the biggest one. And then there's a subcategory, subcategory until, and the last one is like the product name or the title of the article. And sometimes you have query parameters. So 1 equals number 1, 2 equals number 2. They get extracted like this. So let me show you what happens with this. There's a function called URL to df. Okay, so here are my website contains these two URLs, and I want to split them. So the first column is the URL itself, as it is, no change. You get the schemes here: HTTP, HTTPS, FTP, whatever you have, network location. Over here, the full path and the full query. Now, if you see here, the price comes first, here price comes second. It's a bit of a mess. But when we split them here, we see that directory 1 here is number 1, 2, 3. Directory 3 here is empty. And you have this as a table. that you can play with just like any Excel sheet or filtering tool.
That's cool.
This could also be interesting. So once you have these in place, you can say, show me the URLs where the price was greater than 5. Show me the URL where the color is blue, or show me URLs that have a color, or the size is small. Or you can play around, like you've converted the URLs to a data frame where you've disassembled everything and you can play with it the way you want. Is that clear?
Totally.
Great. So I did the same thing for the crawldf URLs. Okay. So here they are. The scheme, the network location, the path, the query, the fragment. We have up to 12 directories. And we have these parameters as query parameters. Next page, from the query underscore is something that I've added just so it's clear that this is a query, because sometimes you might have a parameter that's called path or that's called query. So just to make it clear and easier for you to get these out of the data frame, and these are called directory 1, 2, 3, 4, 5. Okay, so the first question is, like, how full are these? Okay, we have directory 12, but is it like 20% of the URLs that have 12 directories? Is it like 0%? So a quick run of the code can show me the percentage of usage for each element. Now, obviously, these are 100% because these are the elements of the URL. Directory 1, 100%, 100%. As you would expect, they would go down. And you see the percentages, and these are the counts of the URLs that contain anything in directory 5, 6, 7. Beyond 8, it's like pretty much 0.
So 14% of their URLs have at least 7 directories?
Yes.
That's insane, isn't it?
For 5,000 URLs.
I wouldn't want to have to do technical SEO on something like that. That looks like plenty of opportunities to create infinite.
Oh, wait till you see the languages. There's 10 languages on this website.
I'm all set.
Gosh.
Oh, and there are versions of the software.
Oh my goodness. Like, I had to deal with a site that had a much simpler structure, and they were creating an infinite crawl loop by manually injecting rel canonical tags from Google Tag Manager, and it created an infinite crawl loop. And we found it like a day after they installed it or something like that. And it was interesting. And when I see this, my mind goes straight to that experience of like, oh my God, dude, what the heck? So bad, so fast.
Sorry to bring up bad memories.
I know. I still wake up in a cold sweat. Middle of the day.
Yeah. So in terms of queries, there's only like really one that's actually used on 37% of the pages. Yeah. The rest is like 0. Yeah. So this one was used most of the time. So what we can do is the same application we did, but we can use it for the elements of the URLs. Okay. So we can go scheme. We can see that this is how many HTTPs and how many HTTPSs we have. Let's see the subdomains split.
So that HTTP was not an external, because we filtered all those when you did your initial crawl, right? So like they're screwing up their the protocol or whatever.
It's these links are discovered by finding links.
Right. So these could be anchor links then, so the HTTP version could technically be redirected to HTTPS.
We'll see redirects now, but these are not redirect. These are the actual crawled URLs.
Yeah, I'm just saying they're mismanaging their domain. I mean, is what I'm saying. Yeah.
So these are 2 separate domains, 20,000 under docs and 14,000. So we know the split at least. These are redirects because we didn't specify this as a domain as a subdomain to crawl. The path query. Okay, so now we can look at directory 1 and see what it's composed of. So community is 37% of the website. Okay. English, French, Indonesian, Portuguese, Greek, all these languages.
Huh.
So directory 2 is, that's interesting.
Yeah.
Q&A 30%. We have some nans here that don't contain anything, and these are versions of the software.
Oh.
Okay, so there's a version called Dev 2.1, 2.0, and so on.
Yeah.
And you can do query 3, directory 4, and so on. Was it Page or was it Next that was the most
Page.
used?
Page.
Page. Okay.
That was the one that had like 13% or something.
Okay, so here we go. So okay, so it's a pagination thing, page 1, page equal 2, page equal 3,
Yeah.
and so on. So we go to Canonicals. So we have a. Let me show you how this works, because it's an interesting, and actually it's a practice recommended by pandas to when you have chained commands. So these are comments, of course. So I'm going to run this first line, and it's going to give me the crawl df, the whole thing. Okay, so I can give it another command, which is to extract the column that's called canonical.
Right.
So when I run this, it returns this. So the next method takes the return value of this one and runs this method on the return value of this one. So this, do this, then take the output and do this, take the output and do this, and so on. Okay, so I'm splitting by this character, and you get a list for every place, and then I'm checking the length of each of those lists, because I want to know how many canonicals do I have per page. Do I have pages that have more than one or not? And then we take this and say, count the values and don't drop the missing ones. Okay? So as a result, we have 18,000 pages that do not have a canonical tag, and we have 17,000 pages that have one canonical tag. Okay?
Wasn't there one that had 4? When you
Canonical?
Yeah, like I saw 1 and 4. Go back one step, i.e., I don't remember how you had it commented, but one step back, I thought I saw something with 4.
This one?
There. Do you see?
Oh no, this is the index.
Oh, I get it. Okay, humbly apologize. I get it.
No problem.
It's looping through and it's saying at what how many are per item.
This is just like the row name.
Yeah, and it's the count in the second column.
The index.
Sorry.
No problem. So shall we go more, or shall we?
Where are we? I'm not sure where we are time-wise. I'm just kind of spacing out as you're doing this. This is wicked cool.
Cool.
What other functions do you feel like when I've talked with Hamlet about your toolkit, and I know that he's pretty blown away by everything that you've built. My take on it from the outside, not having used it yet, is that it seems like a pretty amazing Swiss Army knife for slicing and dicing digital marketing data.
A lot of these things are pandas, by the way, and most of the functions return a data frame. So once you have a data frame, you could use the full power of pandas. It's at, you have access to all the powerful thing that you can do with pandas. So most of my functions give you a data frame. Like the crawl gets the pages, gets everything, extracts them and puts them in a data frame, and you can do whatever you want with it. The URL to data frame is a data frame. The XML sitemaps gives you a data frame. And because that data structure is optimized and actually designed for these things, you can take it and play with it the way you want. So there's a few things to figure out in Canonicals. There's an interesting case study here, which we couldn't get an answer for, and I have a suggestion, and I'd like your opinion on it, because it's quite tricky with documentation sites. So we can go through this and look at the links, and then look at some of the dashboards that we have.
Yeah, I want to see dashboards. Yes, 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 dashboards.
Show
Sorry,
me
I got
something more
wicked
fun,
excited
please. Okay, so we have two columns. This is the URL that was crawled, and this is the canonical tag on this URL.
Yeah.
Okay. So in some case, so you have two cases: either nan, there is no canonical tag on this page, or there is something here. Okay. Now, when there is something, you have two options. Either this value is equal to this one, so it points to itself, the page, or it points to somewhere else.
Right.
So we can easily extract the ones that point to themselves,
Mhm.
and just like where canonical is equal to the URL. And we can see that we have 1,045 of those on the page, on the website. So we can simply split them the way we split URLs to figure out what these are. Like, I'm trying to figure out what their strategy is. How do they canonicalize? Which pages do they canonicalize to themselves? Like, what's the pattern over there, right?
Mhm.
So a simple value counts over here shows that all of these, this is the data frame where just a reminder, where the canonical tag points to the same page that it's on, okay?
Mhm.
And in this data frame, everything is under docs.djangoproject.com, okay? So this is one thing that we just learned about those URLs that point to themselves in Canonical, which is that they're all under docs, okay? And a simple count of directory 2, you'll see that all of them pretty much are the version 3.1. So version 3.1 pages are pointing to themselves, and that's it. That's the story about, right? Does that make sense?
Mhm.
And yeah, that's interesting. That's me responding very shortly, so we can keep moving because you have so much stuff to show. I'm like, don't blab, Noah. Shut the hell up.
Sorry.
Good. No,
Okay.
it's me being an idiot.
No. So this is the more interesting thing, which is the URLs that have a canonical tag that points somewhere else. And we're trying to figure out what's going on there. Like, what's their strategy? What do they do? How do they think about this? Okay. So apparently we have 16,000 of those canonicals pointing to somewhere else.
Mhm.
So there's an interesting method that Pandas introduced, which is called compare, that compares two data frames. You just give it one data frame and another, squish them together, and you get a diff. So this is a very quick demo of how it works. So I have, okay, so this is df1 and this is df2. Okay, so I'm going to say df1.compare df2. And it's going to compare column A to column A, column B to column B, and column C to column C. The names have to align. You have to have the same columns. Now, the column C over here is exactly the same as this one, A, B, C, D, E, A, B, C, D, E. So it won't show up in the resulting data frame. And if anything is the same, it will show up as nan. So this is the result of running df1 compare df2. So you can see here we have two levels of the column names are like multi-levels now. So A self other and B self other. So these values are the same, so they're not available, and these three are the different ones. So we can extract just these, and we can say df compare, give me the differences of A, remove the missing value, and we can just take the subset where we have just differences in column A. Okay?
Yep.
Mhm.
So we're going to do the same thing with the URLs that have a canonical tag that is different from the than the page it's on. Okay,
Yeah.
so this is a quick example of why we cannot compare URLs mechanically by just doing a text diff thing. So if you see the first URL over here, and if I asked you, is it more similar to this one or to this one? Now, if you mechanically compare, you'll see that the difference here is just one letter. There's an S missing. And here, this is exactly the same, but this is just product ID 1, product ID 2. So if you give this to a text algorithm, I don't know which one it's gonna, because the difference is a single character.
Yeah.
But we know that this is the exact same page because what we care about is the content.
Right.
So this is product 1 and this is product 2. So obviously for us, we think that this one is more similar to this one than this one, right? So the comparison here is semi-semantic. We're still comparing strings mechanically, but we're comparing scheme to scheme, directory 1 to directory 1, directory 2 to directory 2, and so on. Does that make sense?
Yep.
Okay. So this is a comparison between the URLs that have a canonical tag that's not the same as where they are placed. Sorry. Okay. So if we look at the scheme, we'll see that there's 1,019 URLs canonicalizing to a different URL where the difference is HTTP and HTTPS. Sorry, now we don't know what's in the rest of the URL, but we know that this is the element that's different. So this is pointing to this in this case. URLs that have fragments, the other is nothing. So it's canonicalizing to the same thing without a fragment. This is an easy problem to solve. So directory 1, it seems that this URL has a directory 1 value of ES, Spanish, and the canonical tag the URL that it points to doesn't have anything on directory 1.
Oh.
Okay? And all of these are the same thing. So I extracted those URLs, and it seems that this is what they are. So Spanish search, everything search is canonicalized to the default version, which is the English page, which is probably not what you want, because you don't want someone searching in Polish to go to the English page or the Japanese or French. So all these, but there's not a lot of those. There's like 50 something.
So why did they do that? Are they just assuming, did they just say Google crawls in English? So we're just gonna have a rel canonical tag that points to the English version? Like,
I'm not sure. Search, you can go here, but this should be /es, right?
Yeah.
Now the most interesting one, which is the real problem here that we're trying to solve, is the differences between, we're comparing directory 2 with directory 2. Okay, so it seems that everything here is having a rel canonical that points to version 3.1. Okay, or dev.
got it.
So the problem here is that with software versions and documentation, the fact that this is not the latest version doesn't make it any less relevant for me, because I'm running my Django website on version 2.1. I don't care about 3.1. I don't care about 2.0. I care about 2.1. And let's forget about SEO for 2 minutes. This is as relevant, as important for me as 3.1. Because this is not a Wikipedia page where you just want the latest version. Now, the problem is when you introduce a software update, 90% of your pages are the same. So you're introducing duplicates. And when you have 10 versions of software, you have 10 pages that are pretty much the same, which is a very good thing to have from a user perspective. But how do you tell Google that these are not the same pages? Now, what they did here is also misleading, because you're sending me to version 3.1. And even if you search like...
So how would you structure it? Would you send them all to like a subdirectory that's latest? So that that's always the live
I'll show
URL?
you a suggestion, and I'd like your opinion, but
Yeah.
just to show you what happens if I search specifically for version 2.1,
Mhm.
it takes me to 3.1 page,
Mm.
which is not what you want.
Yeah, it's not useful.
So my suggestion, this is just a sample of those. My suggestion, I don't know if you think this is a good idea. So this is the docs page of topic A, and it is valid for versions 1, 2, and 3. Now, when we introduced feature X to topic A, only then did we create a new URL, and we mentioned in the title that it's valid for versions 4 and 5. Does that make sense?
Yes.
It does for me as well. Yeah.
Yeah? Okay, so let's not go deeper. Shall we take a look at some of the dashboards that we have?
Yeah, totally.
Okay.
So what do you want people's takeaway from looking at this notebook to be? That it can do a ton of shit? Well, minus the SBOM. That it's incredibly functional and you can do tons of stuff with it?
Yeah, I mean, it's what I'm trying to do is create a template that we can all use.
Yeah.
And this is an open source template, so you can come and write a comment or fork it and email me and say, look, this is a terrible thing what you did in cell 15. There's a better way to do it. Or, you know, this is cool, I'd like to add this.
Mhm.
You know, an open source notebook. It could be used for mentoring if you want. You can have people come and say, look, show me your analysis on an open source data set, because many times we cannot share client data. So, you know, and you can mentor like 10 people on this, right? You can have them all submit their own version of their own analysis of some other website, and do it. Another thing that can be done is, which I suggested to, we'll talk about this later, which is if there is a cause you care about, or if there's a company that you want to support, we can crawl their website and provide some SEO tips to them and help them out. So this can be used for different ways. These are things that I have in mind.
Got it. Cool.
Okay. So Dash is a Python package, and R and Julia, that helps you build interactive dashboards. So I have a bunch of those over here. Let's take a look at, what do we see?
Please
You
no.
do PPC?
Yeah.
Mhm.
Okay, let's tackle SERPs as well. Okay. Okay, so this is a simple tool to generate keywords for SEM campaigns. So the idea is you generate keywords as opposed to keyword research. Now this is valid for PPC, it's not valid for SEO, because with SEO you want to discover what's going on. Here you can generate every possible combination and see what is working and what's not. Okay, so simply we can take this example over here: Honda, Toyota, BMW. So all you have to think about is the list of products that you want to sell. Okay, and this is easy. You have it already with you and on your website with a client, whatever. Now the challenge is to come up with a bunch of words, not keywords, words. Now these words should have the intention that you're trying to satisfy. Okay, so let's say we're doing used cars. So buy and price would be interesting for me. So these are the match types that you want to have, and you can specify whether or not order matters. So buy Honda and Honda buy, or just the combination without the order, and you can name the campaign whatever you want here, cars, let's say. So you could generate the keywords here and see all the combinations: Honda price, Honda buy, price, Honda, and all the combinations of these keywords. So you can easily say Honda secondhand, used, dealership, and you can easily put whichever. Did I spell it correct? It's okay. And you can generate those, and you get it in the format that's ready to upload. 816 keywords and 408. 408 uniques in 4 ad groups. Each one gets into an ad group. So this is based on one of the functions that I have in advertools. Is called keywords generate. If you run it in a notebook, it will give you a data frame that looks like this one. This function powers the back end of this dashboard, where the user doesn't have to write code. You can just fill these out here, and you get this output that you can download.
I feel like it's a dumb question, but if I uncheck order matters, does that mean that I'm going to get less exact match in the table on the right? Like, what impact does that have?
It's so in some matches the order matters, in some match types it doesn't.
Right.
So it's gonna generate less keywords for you.
Yeah.
So just to make it simple, we can do this, and the order doesn't matter. So we'll get here just Honda buy, yeah, and in the 2 match types that we did. Yeah. But if you say order matters, you'll get the permutations and not just the combinations. Honda buy Honda. Yeah. So this is one thing that was built with an advertools function.
Got it.
Super handy.
Yeah. Cool. Movies. So these are the movies, all-time movies updated as of this date. They stopped publishing the data, so I couldn't update. But here is a filter that you can just say, give me the movies that were released between 2005 and 2015. You'll see the name of the movie, which studio it was produced from, and the number here is the all-time rank of the movie. So you see 137, because these are the top 3 in this date range. But on the all-time ranking, this is 1, this is 3, this is 7. And this is the total sales of each of these studios. So you can do 1990, whatever, any combination that you want. You can also check all the movies. So each one of these dots is a movie. You can drag, you can zoom in like this. Obviously, it's not helpful to look like that.
Plotly?
Yes. So what you can do, for example, is Godfather 2, Godfather 3. So now you can generate your own report for this movie, and you can see where, like, you can take a screenshot of this and show when it was released and how much money it made relative to the year it was released in. So you can see that The Godfather 1 was the top movie when it was released. Number 2, not so much, and so on. SERPs.
Yeah, do it.
Okay, so this is a SERPs checker. So this also is built with a function from advertools, which gets the SERPs of Google. It doesn't do scraping. This connects to the Google's custom search API and gets the official results based on the parameters that you gave it. Okay. Now, the main idea, the most important thing in checking SERPs, in my opinion, is to do it in bulk. Like getting one SERP is cool, but if you're researching an industry, you need like 100 keywords with different variations across different countries, so you get a representative sample of the market, right?
Yep.
So I feel like you just blew my head up. So
Really?
well, no, I didn't. Can I crawl under a rock? Tell us about the custom search API. Have you used that ever, Jordan?
I have not.
So why are we paying SEO tools to crawl SERPs when we could just, I mean, is it that efficient where, like, what are we losing by using the custom search API over scraping SERPs? Like, what's the difference in the data?
You're losing the custom options, the special snippets that are not the results themselves.
Oh,
Like people
so,
also
okay.
asked and
Okay.
videos and stuff, but you can use the crawler if you want to crawl these.
Yeah. Okay.
Okay. So let's do something that's interesting for you. What do you want to know? Which industry are you working on? Or should we do the SEO industry? What, you tell me.
Jordan, you go. I always hijack this.
My go-to is VPNs. So I'll do like VPN. What is a VPN? Why use a VPN? How much does a VPN cost? Top VPN, best VPN.
Okay, best VPN, top VPN. Okay, so let's say we want to do this for 3 English-speaking countries. Canada, US, and let's go with the UK. Now, I've selected 3 parameters over here, and I gave it 1, 2, 3, 4, 5, 6 keywords. So it's going to run 6 times 3, 18 queries, 1 for each combination, right? Now, if you have all the options over here, so if you specify 2 languages, it would do 6 times 3 times 2. So 36 queries. So this can grow exponentially in the number of queries, the more options you give it. Okay? So it takes a bit of time because they have a limit on the speed at which you can send requests. So
what's the rate limit?
100 requests per minute.
Oh, okay.
I mean, it's not slow, but
yeah.
In other cases,
actually, it's twice as fast as what you're allowed to do with Search Console.
Yeah, is it?
I think it's 50 queries per second. Oh, sorry.
Oh, okay. Okay.
Sorry.
No problem.
I'm really not dumb. I promise.
No. Okay. So this is a summary of the so the raw data are here. You can download them, but this is a summary. So we've run 6 times 3 equals 18 queries, right?
Yeah.
So this domain PCMag appeared 16 times out of the 18 queries that we ran. Appeared somewhere.
Yeah.
Okay, which is 88% of the 18, and their average position was 3.06. Now,
and quick question: is this a top 10 results or top 20? Okay.
Good question, actually, because you have a you have the start. Where did it go? Yes, start. You can start. So the default start position is 1, which means the first page. You can give it start 11, start 21, 23, 31, and so on. And you'll get the later results. So out of these 16 times that this domain appeared somewhere on the SERP, it appeared 3 times at position 1, 5 times at position 2, and so on. So this is the heat map, if you want, of PC Mag for these keywords and these countries. And you can see clearly where the hotspots are. And this is a summary of this market that we've just decided to check out. You can add more domains if you want. And you can download. So these are the standard columns, but if you download this, you'll get a lot of data that is optional that might appear, like Open Graph, like Twitter username, like App Store ID, whatever is on the page that Google has, you will have it. Sometimes it's like 300 columns, but
wow.
It's very sparse. Like it's mostly empty, but some of them contain structured data. Some of them contain Open Graph, as I said, app IDs, and so on.
Well, what would be cool is running these results through the crawl analysis feature that you have.
Oh, yes, exactly. So after you get the top ranking pages, you crawl them and you see any differences, if the version that's saved on Google is different, if the meta description is what they used for the snippet. You have
100 per minute. Huh.
So this is the rank, this is the title tag, snippet, display link, query time, total results, and a bunch more if you download it.
Huh. This is really interesting.
Yeah.
I love the heat map and the way that it's laid out.
Is it a good summary of the SERPs? Like that's what I usually use to summarize, like just a heat map for
So
Twitter.
do you feel like you're missing, how much of the story are you missing by not having non just blue links? Like do you feel like you're missing a lot by not having people also ask or rich results?
You're missing something, because these things are like
yeah,
in
they're
your face.
lots of real estate. No, I'm just trying to understand, like in your own analysis, how does this fit in?
No, that's a very important question. So knowing the limitation is, so this tells you more about how Google ranks this link for this keyword, for this country, for this language.
Yeah.
Right. Mm-hmm. The limitation is, as you said, is that yes, my rank is number 3, but above number 3 you have these massive objects that are in my face that I can't detect. Now, the good thing is that you're getting official results. You're not getting banned. You're not. And you're paying for these. Like 1,000 queries cost $5. It's not much. It's nothing, actually, if you compare the time you spend on the analysis. But you're paying for this stuff, so you're not scraping, or you're not getting banned, or you don't worry about these things. But if you need to, you can use the crawler, and you can crawl. You can extract the XPath or CSS selectors of the items that you want.
So this API's cost is how much per URL?
$5 per 1,000 queries.
Okay.
So we just ran 18 here, which is like, I don't know, 17 cents, 20 cents. It's nothing.
Yeah.
Because you're going to spend hours analyzing the data. So $5 per 1,000. 1,000 is. It's
a lot of searches. Yeah.
Yeah.
You basically are getting a sense of an entire topic area for $5.
1,000 is a lot. Yeah.
It's a lot.
And because you can analyze, you can see what people are using for the title tag.
Yeah.
You can do some text analysis here, natural language processing, or just extract certain elements. How many of them do they include? Prices? Do they include comparison? What keywords do they use? Is there anything unique? Can I stand out differently? It's up, like, yeah. Again, this is a data frame. and you can go crazy with it. What's your name?
Let's go Noah. Why not? Because I know it's changed weirdly recently.
How do you know?
Because of that. Because I was born in 73.
Exactly.
Yeah, I was born in
What did
73.
you do here? Wait. What did you do here in 1999? You did something bad.
I know, right?
People changed their mind all of a sudden, but then
I knew things that like I didn't even meet another Noah until 1980.
okay.
And then
Ooh.
in 2000, oh Jordan, what happened?
We're a horrible bunch of people, apparently.
Wow, dude.
I'm not that popular, but I'm consistent. See?
Oh, dude, that's a nice strong growth curve.
Wow. Yeah.
Some of these have like interesting patterns. Like
Let's
if you
go with
see-
Hamlet. Let's see. Let's do our favorite SEOs. Let's go Hamlet.
Absolutely.
And
Oh,
then
wow.
See Hillary in 1992,
oh wow,
That's wild.
she's
and
not as popular.
yeah, and 2008 there was a small peak.
Yeah, weird.
2016, not much.
So we'll go Hamlet. We'll go David.
Whoa.
What?
Oh, wow.
So it's what does that
So
mean?
the minimum number of people to be included here, it has to be a minimum of 5 people using that name for it to get registered in the database for
Yeah.
privacy reasons.
Yeah.
So who
There's
else do you
very
want?
few. So I'm seeing that's very few, right?
Yep, absolutely. 2004 there were 5 people. 2011 5 people. That's it.
That's it. So the other years there are 0 Hamlets in the United States. Holy shit! Oh my
That's what it
god!
says.
Well, no, it would be less than 5 people.
Oh,
Sure,
less-
sorry.
could be-
Yes, you're right.
yeah.
Absolutely. Less
It's
than
still
5 could
very,
be 0,
very-
could be.
Huh. Wow. Who's? Let's see. Let's think of. Let's go Ashley. ASH.
Now, the interesting thing about many of those names is, as you can see, so Ashley is one of those names. How do
Yeah.
you spell Ashley?
Yeah. Right.
EY?
EY. Yeah. And this is for Ashley Berman Hale.
55,000 in
Wow.
1987.
Wow. That was very popular. Seems to me.
And then
Less so. Huh. And our friend
So-
Ashley Berman Hale is in that I don't know if she's in that peak period, but she's definitely on the ascent.
maybe we can do tweet your name every day, like get someone's name and
that'd
mention
be
them on Twitter. Look at what happened with you. What are you doing? There's a
Wow.
lot of like it's.
What
like-
about Robin? ROBIN. Oh wow. And that sort of corresponds to when the TV show was just starting.
Probably.
Yeah.
The biggest was, I think, John and Mary.
Yeah.
Like,
I assume they're massive.
Wow.
where's Mary? So it's not clear what happened. This is, I've seen this before, 1960, but maybe John Kennedy.
Hmm.
I don't know what happened in 1947 for John to peak.
Can you do JUAN?
NN?
That's perfect. Just one N at the end. Yep. I was just wondering. Yeah, perfect. There we go. I was wondering what impact we'd see, like as the U.S. gets, less. As we get more folks who are Hispanic, I was wondering how that would impact the growth curve.
Sure. Yeah. That's how you would probably do it. So you'd
Yeah.
put a bunch of names here from a certain country,
Yeah.
Hispanic, Italian, Indian, whatever.
Yeah.
And you can check.
Oh, that's awesome.
So yeah. More?
Yeah, one more. I don't want to do violence though. No violence.
No. Don't worry. We're not gonna get there.
Happy.
Trending on Twitter.
Yeah.
Sure.
Okay, so you know the trending topics on Twitter, and this is also a function from advertools.
Yeah.
You just send it a location, any one of those supported, and it gives you what's trending. So
Wow,
which locations do you want?
let's go Toronto, Canada.
Toronto, Canada. Anywhere else?
Denver, Colorado.
Denver, USA.
Yeah, that's
Let's do something else in Canada, just so you can see.
Vancouver.
Yeah, let's do Vancouver. Yeah.
Here's Vancouver. Okay, so this is going to go to the Twitter API and request the tweets that are trending right now, the topics.
Did you just get that huge snowstorm, Jordan? Would you expect to see snow?
Snow wise, we have not gotten barely any snow. I know New
Oh,
York got
because
hit
the
really
U.S.
bad.
just south of you got hammered.
Yeah.
Really?
Yeah.
Yeah.
We didn't get it.
What is-
GOT7. Yeah.
What is that?
So this
Game of
is
Thrones.
Oh,
okay. So this is the difference between Vancouver and Denver. Now you can click on those boxes and get the actual number, and the raw data is also here, so you can tweet. This is global tweet volume. I need to fix this. It's not clear because it gives you the wrong impression that in Toronto there's 1 million people tweeting about GOT7, which is obviously not the case because the number here is the exact same number here.
Yeah.
So I just need to fix this to global tweet volume.
What is so guys, I feel stupid. Is Game of Thrones doing more seasons? Is that brand new?
That's my question exactly, wasn't it?
Oh my god, I'm so excited.
Last year.
Yeah, no, I'm guessing GOT stands for Game of Thrones.
Yeah, who knows?
It could be something else.
Huh.
But that's interesting. You actually have, what is that? You have Pence as well trending in Vancouver, Canada.
That's too bad.
Where's that?
Right, one more. Yep, there you go. Oh, down.
Subin? Oh, sorry. Yeah.
Pence. Yeah.
I think that's a band, guys. I'm thinking it's a like a yeah, it has nothing to do with Game of Thrones. I think it's like a Korean boy band. A Korean boy band.
I wouldn't be surprised about that then.
That's funny.
Could be.
Huh.
No idea.
Interesting. I guess they're blowing up.
These.
So were they bigger in Vancouver than in Toronto?
What?
That as a term?
No, that's the problem. It's the number of tweets is global. So
okay.
We know that it's trending in Toronto and Vancouver, but Twitter gives you the number of global tweet volume. So it's a bit misleading in this way, but
okay.
I think I just need to clarify that this is global tweet volume.
Okay. And based on the restrictions of the API, you can't get more localized, right?
Yeah, these are the available locations.
So I'm doing a bad job communicating. What I mean is, based on the API, can we get an actual volume by location, or are we just?
I don't think so. No,
that's
I
what
don't think so.
Okay, got it.
Because the numbers are exactly the same.
Got it. Okay. That's what I thought. I just wanted to make sure that I didn't misunderstand the API. Okay. Wow, I like it. That's really fun.
So this is the next step with doing Python and data science. If you want to, you can convert your functions into interactive dashboards where you or your clients or your colleagues can interactively explore stuff. And this is like completely no code. This is an application that you can just give to people. And to give you an idea about how complex and massive this is, this app, the one that is for tweets, contains a grand total of 163 lines of code.
Holy schmoly.
That's it. That's the app.
Wow.
Here's the app.
That's impressive.
Well, that's not my genius. It's Dash is great. So you create a drop down with a single line of code. You create a chart by just saying dash dot chart. I mean dash something else, but it's as simple as that. So it's very interesting. It's all JavaScript, as you can see, but I've never written a line of JavaScript in my life.
That's too
And
bad.
all this and all this is written in Python.
Yeah.
Wow.
So this could be a second step. Like this is going to be the next PowerPoint, basically. You know, when you're working with clients, and this is going to become. This already is a more important thing, because when you work, you're working with like 17 data sources, right? You have 3-4 SEO tools, you have analytics, you have Search Console, and you want to see the impact of the SERP position on and the bounce rate and page views per author together in one table, and you want to visualize it and you want to do something with it. So yeah.
You know what, I couldn't agree with you more. I think that's why I'm personally so bullish on like data pipelines, is
Absolutely.
because we need just like one aggregated location for all of our data, and then we can slice and dice and analyze to our heart's content.
Absolutely. And there is no one size fits all here, because my client X has a different database of their ticketing system. They don't care about Twitter because they don't use Twitter. They care a lot about Instagram, and they publish on YouTube, and they're very heavy on SEO. So these are like my 4 main things. Your other client might have a different mix. And even within those platforms, they would care about different things for different clients. Like Google Analytics gives you like 300 reports, or I don't know how many, but you just want the 7 ones that are worth combining and tracking on a daily basis. Now, if you want to dig in, or if you want to drill down more, you can go to Google Analytics and look at the numbers. But as you mentioned exactly, Jordan, every day I just want one place where this is my good morning. You know, I see the main stuff that I need to see. If there's a red flag, I can look. If there isn't, then everything is fine. And the amount of data, like the sources, is just expanding. Like
Yeah.
I remember having access to Google Analytics and Search Console and Google AdWords. Like I have a full view. Now any small client has minimum like 7-8 sources. Like that's like a company that has a website and an app. That's it.
Yeah.
So yeah, this is going to become. It's already, I think, crucial. And yeah.
So we're getting towards the end here. I just wanted to wrap up our soapbox moment and ask the question this way. I've seen you write that digital marketers are data scientists. Can you tell us what people who are getting into automation, how they should approach the process of becoming a data scientist, and how they can get from 0 to hero efficiently? And also, like, why is it important?
Great. If you want, we can go through the data science Venn diagram.
Yeah, that'd be
That's
sweet.
a bit. You see my screen still, right?
Yep.
Let me see, which one was it? I think this one is the one that it's been used so much, but it's definitely useful. So there was a description of a data scientist, which is a person who knows more statistics than a typical software developer and is a better programmer than the typical statistician. Okay. Now, a third very important element is domain expertise. I don't care how much statistics you know. I don't care how much hacking skills you have. If you don't know how Google crawls websites, what an XML sitemap is, how robots.txt files behave, you're not going to be able to provide any much value. Does that make sense?
Mm-hmm.
Mm-hmm.
And here, like, you have the limitations. So hacking skills with statistics gives you a machine learning person. Now, the danger zone here is the danger is when intuition is needed. Intuition meaning, like, if you see like all the stuff that you saw on the crawl data set, you immediately saw like, why is this doing? This is weird. This is very bad. This is someone who's not from the industry wouldn't have this intuition, right? Or if you gave someone like me a data set, a medical data set, I'd look at the numbers like, okay, heart rate, that much. It would be completely meaningless to me because I'm not a doctor. I don't know how to interpret the data. I can visualize it, I can slice it and dice it, but I wouldn't understand it. So the other combination here is traditional researcher, someone who knows statistics very well, is an expert in a certain area. Let's say you're a psychologist, you know psychology and how humans behave, the emotions, the nervous system, and you know how to run research, you know how to do experiments and all these things, but you don't know how to use computers in an efficient way. So you're stuck with manually doing things. Hacking skills with domain expertise, the danger zone here is when validation is needed. So you need some statistics knowledge to make a valid statement. Like, can we say that this correlates with that? Can we say that this causes that? Can we say this is where this comes into play? So the three things together give you this data science person. Now, my suggestion is, when you start, if you just search for a data science course, you're going to land right here. Okay, you're going to start immediately here with a bit of programming, a bit of statistics, and a bit of a topic to analyze. So what happened, I can share what happened with me when I learned. When you do web development, your hello world moment is when you create a page and you can display it on your browser and it says hello world. Great.
Yeah.
The hello world moment here is when you open your Jupyter notebook and you get a CSV file and you see the data frame. Okay. So, and this makes a huge difference subconsciously without knowing. If you build a page that says hello world, without knowing it, without thinking, spontaneously, if you like that thing, you're going to start thinking about, how can I make it nicer, better? How can I change the font? How can I make it scalable? Because you're in building mode. You're forced, or you're not forced, but you naturally go into, how do I make this bigger, better, more scalable, more secure, and so on. But if you shift the angle slightly and you open a data frame and you learn that you can get the second column by doing this, you can get the minimums by doing that, and then you start, well, can I get the rows that contain the word hello? Yes, do it. What else can I know? So you get into an insights mode. You get pushed without knowing into an inference and insights mode. And this corresponds directly to what we do in marketing. Because what we do is we use a computer to analyze data to solve a practical problem. We're not here to develop apps. I mean, if you want to, then great. But as a general marketing person, SEO, social media is here. Like, you're naturally here. You use a computer. Now, you might use Excel, you might use GUI tools, you know some statistics, you know what an average is, you know what a maximum is and a minimum is, and you have domain expertise. Now, each one of us has a different combination of these things. But if you start with a data science course, you'll start here. You'll open a data frame and you will analyze the flowers data sets. Okay, interesting. get the minimum of the petal length and the petal width and these things, and then you'll analyze another data set. And one moment you'll say, wait a minute, let me analyze my own data sets. Now that I know how to open a data frame, let me get some Google Analytics data. Let me get some crawl data. And you start seeing stuff that you can do like we did in the call.
Yeah.
And you get hooked on this approach, and it will feel natural, and you'll get productive nicely over here. Does that make sense?
Yes. Do you feel so for you, what was the missing ingredient out of the Venn diagram? What did you need to learn?
These both. I have some domain expertise in what I do.
Yeah.
My programming was zero, literally. I've never programmed before. I mean, I went to business school, so we took some statistics, but I mean, compared to the data science community, I'm like, I can count 1, 2, 3, 4.
Because that's the piece of the diagram that I'm missing, is the statistics knowledge.
Yes, me too. I mean, I'm still beginning, but when we say statistics, like the important thing is to land here.
Yeah.
Okay. If you want to learn Python, you're going to land here. That's a different Venn diagram.
Right. Totally.
You're going to get stuck into stuff that's for software developers, but you don't want to become a software developer, right? I mean, if you do, then sure, then you're changing your career path.
Right.
Absolutely, that's fine. But if you start here and you learn you learn how to open a data frame and start using it and start visualizing it, then there's this virtuous cycle where, okay, I'm doing something useful. I'm doing things at work for work that I can see some light. But if you land here, classes and multiple inheritance and special methods and
So this has been awesome. This has been really great. I'm so glad we got to do the call.
I'm very happy to share this stuff with you and meet you guys finally.
Well, what's really good for me, I hate to be selfish here, but it's like, I'm so stoked that we're doing this at the end of 2020, because my 2021 goal has been to learn how to leverage Python for our own SEO practice. So the timing is perfect. Like,
great.
Now I can bug you on Twitter.
Absolutely. Please do. Please do. My problem is that I'm not getting enough feedback and questions. Like, there's the package is being downloaded, but tell me what you think. Something is clear, not clear. You have suggestions. I'd love to hear from everyone.
I just saw that there were a crazy number of functions that all looked really useful, that once I understood Python more, were going to be just the perfect jumping off point.
Great. Yeah, hopefully that's gets you started with Python here, and then you expand the circle and the Venn diagram.
Jordan, last thoughts?
Holy schmoly. Yeah, this is a lot to process, and like,
sorry.
No, it's good. It's good though, because like as Noah mentioned at the start of this call, like historically I've only done JavaScript. I don't know Python. So as you're going through this amazing library you've built, I'm trying to think, how can I leverage this amazing tool and library that you've put together, but with my level of knowledge. And the first thing that comes to mind is, pushing out serverless functions with your library installed on it. So anyways,
right.
that's where my mind is going.
If you've done JavaScript, you're familiar with databases, right?
Mm-hmm.
A data frame is a table. Actually, the database is the original object. So in the sense that a data frame is a rectangle of columns of the same number of values, and each column is a unique type. So it's an integer, it's a date time, and all of the operations are going to be familiar for you. The group by operations, the filter, the join, left join, right join. It all comes from databases. But the data frame is designed for data analysis, not for storage and retrieval.
You're reading and
for
writing
someone,
to CSVs, right? You're reading and writing to files the whole time.
yeah, but you're not reading and writing all the time. You're reading once,
yeah,
and you're analyzing the hell out of it a million times.
Yeah,
and it's more designed for your analysis. Now, once you've run the analysis and you want to do it in an application that's scalable, then you can either move it to a database or have a subset of a data frame, depending on what you're doing. So if like for you guys, you're already familiar with programming, I would suggest pandas, basic Python, and some Plotly. You'll get started very fast. Like the basic data structures in Python and how they work: dictionaries, sets, lists, and tuples. Function definitions, you don't need to learn that. You just need to learn the syntax and how it's different from JavaScript, I think. And access to data sets and domain expertise you already have. So it could be interesting because you're not just practicing on the airports data set or the flowers data set or the volcanoes, which are cool, but you're analyzing stuff for your own work and clients, hopefully. I talk too much.
No, we're good. This was awesome. So I just want to say thanks so much for coming on the show.
Thanks for you guys.
One thing that I'm totally sure of is that we're going to want to have you on for round 2 after we use the tool.
I'd love that.
That was one thing that we really enjoyed, was that we got Hamlet to come on twice. And I think once we get a lot of this under our belt, it's going to be really useful for us to actually, what'd be neat would be to kind of go through a session and do like an SEO analysis on a site and try and keep it small and useful, but so that someone can kind of use the toolkit more than kind of going through how the functions work, but actually doing a task or doing a job with it. That would be a cool.
Wonderful. Absolutely. Yeah.
Awesome. Okay, everybody, this was another killer episode of Agency Automators. Jordan, you rock. Thank you.
Thank you, Elias.
Yeah.
Thank you, guys.
Elias, you rock.
Honored with you guys. Thank you very much.
Thanks. Okay, everybody, have a great day. Keep automating and see you on the next episode.
Bye-bye. Thanks.